Welcome to EZMathTV. We have another video in our statistics series, Inference on a Proportion. And this is following our test for normality, but we don't need to do tests for normality on a proportion because of the central limit theorem. So let's look at the question that we're going to answer today. We want to infer something about the population when we have a sample. So let's read. A sample of 150 incoming college students was taken, and the answer to "Are you left-handed?" was recorded. In the sample, it was found that 15 students identified as left-handed out of the 150. So we're being asked now to construct a 95% confidence interval, or essentially basically an estimation interval. So that's another uh, description of it. An estimation interval of the true proportion of all incoming college students that identify as left-handed. So that's what inference is all about. We're going from a sample and we are inferring something about the population of all incoming college students. And because of the central limit theorem, we can do that, provided that certain conditions are met. So we need to be confident, or we need to make the assumption that these 150 are representative of the overall population of incoming college students. Okay, so that needs to be stated somewhere, that that we assume that the random sample of 150 incoming college students is truly representative of the entire population of all incoming college students. Secondly, um, we need to make sure that all of the students that were surveyed are independent of each other. So like there's no like obvious relationships between them. And we can assume independence since it was a simple random sample. The third thing is that we need to check the success failure requirements. So let's talk about that here. Um, so first of all, let's make a note that random variable x is either yes or no. So you basically have a random variable x that represents the actual answers that people gave to the question, yes or no, and that is a categorical random variable. But the proportion itself, so when we look at the proportion of students who said yes, that is a numerical random variable because it's going to be your number of x's divided by the sample size n. So we defined that as p hat. We called that p hat. That's your sample proportion of successes x divided by sample size n, or trials n. Okay. And that is a numerical random variable, and it takes on a value between 0 and 1 because it's a proportion. Okay. 15 divided by 150 is going to give you a decimal value, and that's what a proportion is. So let's check our success failure requirement. The x's were 15, and then n minus x is 150 minus 15, which is 135. And both of those numbers are in fact greater than 10, so we may proceed. Okay. So let's look at how we actually come up with an interval estimate for the true proportion p using StatCrunch. And we're going to have to use these numbers. So we need to remember the x equals 15 and that n equals 150. Okay. So we need to remember all of that. And the way we do this in StatCrunch is we go to the Stat menu, and instead of going to the calculator, because that's just calculating areas under a curve, we are going to do proportion stats. So we're looking at uh, finding a confidence interval of a proportion stats, and then one sample, and then with summary. So somehow it got messed up. So let me go back to that proportion stats, one sample with summary. Okay, so at the top of our pop-up window, it should say one sample prop summary. All right. So our number of successes is 15. Our number of observations is 150. And we're doing a confidence interval, and it's 0.95, which is 95%. And then the method is called standard walled. All right, and I'm going to make a confidence interval plot so that we can talk about what the result is when we see it. So I'm going to hit compute. And there's three numbers here that we're going to want to write down. The standard error, the lower limit, and the upper limit. So let me pull that document up again. And SE is standard error, and that is 0.02449. Let's make it 0.02449. And I'm just writing that down because that is the standard deviation for my p hat. So depending on what I'm going to be asked next, I may need that information. The lower limit of our confidence interval is this 0.05199, which rounds to 0.052. So that's going to be 0.052 because of the 9 next to it. And then the upper limit is 0.148 or 14.8%. So so what that's basically giving us is a margin of error in our calculation because we just took a sample. We don't know what the true proportion is, but we're basically saying that with 95% confidence, so 95% confidence also means that there's a 5% error, type 1, that the true proportion could, in fact, be outside of that interval. So the 5% is a likelihood or a probability that the true proportion could actually be outside of that interval, and that's an acceptable margin of error in most cases. Um, sometimes you have to change that, adjust it a little bit because the actual margin of error that's acceptable might be higher or lower in certain circumstances. But for most circumstances, a 5% likelihood that you could commit a type 1 error is acceptable. So I'm going to push that off to the side again. So let me just show you in the form of an actual interval here. So you're seeing the actual interval in front of you, and the proportion of successes is our interval is centered at 0.1 because the 0.1 was our p hat. That was 15 divided by 150, and that's about 10%. So, so p hat is at the center of our confidence interval, and then the left value is the lower limit, and the right value is the upper limit of our confidence interval. And there's a pretty wide margin of error because our sample size was 150. It wasn't really big. I mean, it's decent size, but it's not huge. And the larger the sample size, the smaller, the more close that you can get with this confidence interval. So at least it's we can be 95% certain that the true proportion is at least below a certain threshold, like um, it's below, with 95% certainty we can say that it's below um, below 15%. you know, below 15%, but higher than 5.2%. All right, so we're going to be using those numbers over here. And here's my question. So the sample of 150 was taken, 15 said they were left-handed, and there you can see is our confidence interval from 5.2% up to 14.8%, not including those. Okay. So the statement that we would make as a result of that is the interpretation here. That's part A. So our statistical interpretation is that that we are 95% confident, 95% confident that the interval from 5.2%, so 5.2 is your lower value, and then your upper value is 14.8. So the interval from 5.2% to 14.8% contains the percentage of all incoming students that are left-handed. So again, we are coming up with an estimate for the true percentage or the true proportion of all incoming students based on the sample of 150 that we have there. The symbol and value of the point estimate then was p hat. P hat was our point estimate. And remember, that was 15 divided by 150 times 100%. So that is our 10%. 10% is the center. I mean, if we're not sure about that, we can go over here and calculate what is 15 divided by 150, 0.1 times 100. So that's 10%. And then the margin of error. The margin of error is going to be our upper limit minus, so we need parentheses, take your upper limit 14.8, subtract your lower limit 5.2. So upper limit minus lower limit, close parenthesis, and divide by 2, because the margin of error is the two halves of the interval, right? So that's 4.8%, which isn't too bad. 4.8% plus or minus. So that means that another way of stating your confidence interval could be, you could say that the true proportion of college students or incoming college students who are left-handed is about 10% plus or minus 4.8%. 10% plus or minus 4.8%. And the numbers belong on the number line here. So our lower limit goes first. That's our 5.2%. Our point estimate is in the middle. That's 10%. And then our upper limit is all the way on the right. 14.8% goes on the right. So that's how you construct a confidence interval on a proportion. I'm going to hit submit, and we are done. So like, subscribe, comment down below if you have any questions. Please share these videos with people that you think might find them useful. And there we go with confidence interval on a proportion using StatCrunch. See you in the next video.